The purple sheets. Okay, so as you see, there aren't too many. There's only two organisms on this list that are pathogenic, and that's Entamoeba. Oh, three. No, two. Three. Sorry, three. Entamoeba histolytica, and then, hey, where's Trichomonas? Don't I have it on here? I didn't put Trichomonas on here. It should be, though. I'll add that. We'll look at it, but then I'll write it up on the board or something so you can add it. I don't know if I have it on separate. Anyway, so actually, Entamoeba histolytica, Trichomonas vaginalis, and Valentinium coli. Valentinium is a ciliate, a totally different phylum, but I threw it in here because we have to put it in here somewhere, and it's very easy. It's a nice big one, so we'll throw it on the list for today. So let's start with Entamoeba histolytica. Now, but we're going to have some others that aren't pathogens, but the important thing here is to be able to tell it apart from the one that's pathogenic in a diagnostic setting anyway. Very good. Okay. I've been thinking about Giardia during class, and now I got to switch my brain over to the amoebae. They're a little difficult to tell apart sometimes, especially E. histolytica and E. coli. Don't get E. coli confused with Escherichia coli, Escherichia coli. You always talk about E. coli on the news, on TV, and microbiology. That's a bacterium. This is Entamoeba coli. In fact, I shouldn't even abbreviate E. coli probably, because that's Entamoeba coli. It's non-pathogenic, but it looks an awful lot like Entamoeba histolytica. There'll be some ways to tell them apart, though. Okay, so if you look on the first page of your handout, this is from a lab book. Okay, this is when we still had the phylum Sarcomastigophora and so forth. So don't let that throw you. But this table here has some good characteristics that can help us to tell the troph consists of these amoeba apart from each other. So I've included that. In your textbook, there's also a table, very similar, with the same kind of information on it that you might find very useful. Your textbook also has pictures of most of these things. So if you've not yet cracked your $200 textbook, you might want to take a look at least look at the pictures. Okay? Get something out of it, because there's some really good pictures in there. Just a little spiel for the textbook. Okay. All right, so here's Entamoeba histolytica trophozoites. You see there. Here's a 10 micron bar, so most of them are bigger than that. So if we look at, let's take a look at this table. I'm going to leave the lights on because I think we can see it fine. Trophozoite size at E. histolytica, 18 to 25 micrometers. You're not going to use size very much. Size is not very dependable, especially just looking at one. Usually, except for Endolimax nana, when we look over to the right a little bit, it's a lot smaller. Okay, so you will, in that general sense, E. nana, you'll be looking for something much smaller. That doesn't help us much with these other three that we're looking at. So, okay. The cytoplasm of E. histolytica is finely granular, non-vacuolated, and sometimes they can have red blood cells. Ingested RBCs is diagnostic. E. histolytica is the pathogenic one. And when it becomes virulent, it causes damage to the intestinal mucosa, which will induce bleeding, and it feeds on the contents of those cells. It's digesting the intestinal cells and damaging them. And so sometimes it will have food vacuole. It says non-vacuolate. In other words, it doesn't have a great big old vacuole inside of it like we'll see in some. But it does have food vacuoles. Sometimes the food vacuoles will contain a red blood cell, which is what you see right here. See my pointer? Okay, that's an erythrocyte in there that this thing is eaten. The others will not tend to have that. They will not tend to have red blood cells. So if you happen to see that, I'm not promising you that the one I put on the practical will have that. But if it does, that is a diagnostic characteristic. Also, sometimes the Entamoeba histolytica will have these Charcot-Leyden crystals. See if it says that somewhere. It doesn't say it on this one. Okay, but that is a characteristic that sometimes you probably won't see it on the practical, but while you're looking for these guys, you might see these real fusiform crystals in there. Let's see what, what John Sullivan has to say about that. Here, trophozoites of E. histolytica stool smear, a nucleus with a central endosome. All right, I didn't talk about that yet, but the endosome is supposed to be centrally located. This is as opposed to E. coli that has the eccentric endosome. Yeah, I see y'all taking pictures. I shouldn't say this out loud, but you really can steal this off of this computer, and you'll have this whole thing at home if you do that. Okay, I didn't say that. John Sullivan, I shouldn't say that. I don't know him very well, but he did go to a lot of work to do this to try to sell it, but I'm not sure it's even all that readily available right now. So here it's in, all I'm saying is I'm going to leave it in the lab for your use. Okay? I told you that before, but apparently y'all weren't. But anyway, if you're too honest, I don't know, but it is transferable. So here it's a central endosome. Eccentric, you hear people called eccentric, that means they're off-center. That means they're kind of crazy or something, right? But that means off, literally it means off-center. So E. coli, we're going to see, has an eccentric endosome, but Entamoeba histolytica is supposed to have a centrally located one. Again, you've got to look at more than one cell for that to do you much good. Okay, sometimes that's not, none of these things are absolutely hard and fast, at least very few of them are. But that's one that if you look at several examples, that should be the case. Okay, central, oops, hang on. This mouse is hard to work on without a pad here, let's see. Okay, so we also have a fine peripheral ring of chromatin. Chromatin, you know, is DNA and it stains dark. And in these guys, it forms these kind of lines or rings around the nucleus that are stained. So that gives us a somewhat characteristic appearance. I'll show you in a minute. That's a little different from E. coli. Trophozoites would be found mainly in loose stools. Infection occurs when the cyst is ingested. We need to talk about that, which you already did. That's how it is with Entamoeba as well. Although infections may be asymptomatic, this parasite is capable of causing ulcerative colitis, blah, blah, blah. We'll talk about all that later. Charcote Leyden crystals, representing the crystallized contents of granules from eosinophil leukocytes. Okay. That's a type of white blood cell. So when they get digested, the contents become crystallized and form this thing called the Charcote Leyden crystal that you see with histolytica, but none of the others. Okay, and so he found one, took a picture of it. I've seen a couple of these in my 20-some years of teaching parasitology labs and parasitology class. And we have some slides that have these, because I've seen them in here. I'm not going to go looking for it for you, but if you find one, holler and we'll all come look at it. And this is what it looks like. It is diagnostic for Entamoeba histolytica. Okay? So the main one that this one's going to be hard to tell apart on the trove is from E. coli. So let's pull up E. coli and look at it really quickly. And I think telling the cyst apart is going to be easy. Telling the trophs of these two apart is probably one of the harder things that we have to do. Don't let that freak you out if you get the